Thank you. All right, so welcome. My name is Mattias Jönsson. So just quickly, a quick show of hands. How many speak Swedish in the room here today? Okay, yeah. So it's a good few. So Pepper, who I brought with me, we're doing this presentation, well, sort of together. uh, you're welcome to have a chat and interact with Pepper later on after the session. But I'm going to show you a little bit of what we're doing with the robot. It is set to speak Swedish, so unfortunately you do need to speak Swedish with it. Um, but it works, and you're free to interact with it. We can see if we can get this to work. This is I should stress this is our development robot. So I just nicked it from our development team working on I think 3 different projects on it. So she's a bit it is a bit shaky from time to time, but we'll see. Hey Peppa. Peppa. Hey Peppa. Ah, hey Peppa. Yeah, she seems to be pissed off. We'll have to look into that later on after the session. Um, but anyway, so I'm going to talk about a couple of AI use cases. So as I said, I'm Mattias Jönsson. I work as a CTO and lead data scientist at a company called Sigma Insight. So we're a little company within the Sigma group. You can reach me at my email address. My social media presence is very very limited, but I run and work with a team of data scientists and AI engineers and yeah, a group of odd people across Sweden and India, I would say. Um, yeah, that's pretty much it. As I said, I'm going to talk about 2 use cases. I'm going to talk about the Compass robot, but I will start with talking about what we're doing for a construction company. Um, and let's see if
We at Arrow work together as
no,
an ecosystem, together with our partners and vendors to create the next generation of
can
infrastructure.
I get the sound?
Engaging in this project, we have learned that health and safety are core priorities in construction.
Can you hear?
With the Microsoft platform, our customers can improve safety with new kinds of solutions. Working in partnership across industry, we can innovate together. Using modern cloud technologies such as AI and machine learning, we're able to bring new ideas to life.
Working together is the key to digital transformation. Data is the new foundation.
Safe workplaces are one of NCC key focus areas, and the work is never completed. One of our 3 high-risk areas is heavy crane lifting.
In this test, we explore if digital barriers with object detection can alert personnel and prevent them from being under suspended loads from a tower crane. We knew early on that in order to succeed, it was imperative to have competence diversity. So that is why we have partnered up with companies from other industries.
Our Azure-based solution detects people under the crane using deep learning on real-time video. All processing is done in the crane to instantly alert people underground and to avoid sensitive data in the cloud.
A construction site is a complex and constantly changing environment. So far, we have shown that the technology works for us. So I'm convinced that a continued collaboration in this partnership can solve our safety challenges when working with the tower crane.
All right. So brief introduction. So that's one of the cases that we are working on. We have the first version in production at the moment. I'll show you some images of that. So as the video explains, NCC does have, and the slides are in Swedish unfortunately, but I'll try and talk about them. So as I said, NCC, they have these massive tower cranes. They are absolutely fundamental for the success of their construction sites. It's a crucial piece of equipment, and they often have multiple of these. The problem and a big challenge is that when the crane operator sitting up here is trying to do something, I mean, they are like 60 meters long, these these cranes, and like 60 meters high or whatever. So the distance from the crane operator is huge. So say that you want to do a lift, massive objects across, sort of on the other side of a building. You don't see anything, so you don't know what's going on, and you have this massive area around the crane, and it is dangerous. Right? So you lift things that may potentially weigh hundreds or even thousands of kilos, which may loosen, they may drop, or something may happen. There are many accidents that happen in construction sites due to just these lifts. So there are principles, there are rules. You are not allowed to go underneath the crane when it is loaded. So when you have things on the crane, hanging from the crane, you are not allowed to be there. But of course, I mean, things happen all over you, and cranes pass by, and yeah, you're on a tight schedule. You need to complete this before the end of the day, or I mean, it's a very sort of hectic workplace, and it is a challenge. So that's what we're trying to do. So this is basically a project where we have cameras and equipment mounted onto a crane. So the first crane that has gone live is a crane in Uppsala. There's a new building being built for the university. So it's a big building. The project is ongoing. Started, I think, last year sometime, and it's going to continue for a year or two more. So that's been the first crane that's gone live. If we look at the solution, what we're basically doing here, it is actually quite interesting. So of course, we do a lot of Azure development. So there's an Azure backend to both train machine learning models, but also to receive the IoT data that is being generated. So we use Azure Machine Learning. We use TensorFlow for models for object detection. I'll briefly talk about how that works. Nothing fancy. It's basically one of the traditional architectures for doing that. We have the trained object detection AI model is hosted as a Docker container in Azure Container Registry. That is then pushed out to a computer, GPU accelerated computer sitting in the crane. Where that all the cameras are basically connected to. So that is doing all the inference from the model. So all the scoring and detecting people and objects, all of that happens on that machine directly in the crane. The reason for that is that we don't want to send potentially sensitive data to the cloud and store there. So we want to sort of keep all the scoring and all the inference as close to the cameras as possible. So what happens is we detect objects, people, vehicles, and the crane hook, and we then send all the metadata related to that object. We send that as an IoT message into Azure. So there's a constant stream of messages that happens. We pick it up with Azure IoT Hub. We process it with Stream Analytics, where we can do things like aggregating over time frames and do some very basic, at this point, very basic analysis, region analysis, sort of geospatial analysis, if I put it like that. Then we use an engine or a framework called Signal R that basically pushes events out to a real-time dashboard. We also do use some Power BI in there as well, but this is actually because we also need to, if we have an incident, we may want to show the actual images coming from the camera feeds in there, and that's quite difficult to do in Power BI. So. So very briefly, this is what we have. An object detection algorithm. Just briefly talking about that. The traditional world of sort of object or image recognition is you have one image of one thing, and you try to detect what is that thing. Object detection works a little bit differently, because here we say, well, actually, I may have a scene in my image, and I may have one or more objects. I may have one or many or even zero objects. So understand that image and try to basically, and this can work in a number of different ways, but basically identify regions. So regions that look interesting, where things seem to happen in the image. That is basically then taken out into a region of interest pool, where you basically have then a traditional sort of image recognition or object recognition type model. So then it basically cuts out and says, okay, this region of the image seems to be quite interesting to look at. Okay, what is this? And we basically then get these kind of things, right? So it would say, okay, this thing over here, this part of the picture, that looks reasonably interesting. This seems to be an object. Okay, identify that, pick that out, and then interpret what type of object there is. This may also be quite interesting, and so on and so forth. And it looks at overlaps of regions and so on. I won't go into this in too much more detail, but just to sort of explain the fundamentals of that. So what we do, we use transfer learning in this case. So we use pre-trained model for the basic layers in our deep neural networks. And we've annotated, so this says 500 plus images. I think in the production version of the model that is in use now, I think we had close to 1,000 images annotated. So that's the sort of boring work you punish people with when they don't deliver in time. Okay, then you'll get 300 images to annotate. It's really boring, but yeah. It needs to be done. So we're annotating vehicles, people, so construction workers, and the hook of the crane. And then just to see here, we've used just highlighted where the people are. So these are the kind of images we're seeing. This is done in an open source tool at the moment. Now Azure Machine Learning has included functionality to also do this tagging. Just came out, I think, a few days or a few weeks ago. So we're going to transition into that. and basically this is what we then get. So we then pick up the construction workers and vehicles in these images. Very good question. It is not based on movement as of right now. Version 1 is not based on movement. Version 2 will be. So that is something we are currently working on. So for the next version of this. As I said, we're also doing sort of spatial analysis. And I'm not even sure I would like to call it spatial analysis, but we are identifying sort of, okay, where is the crane beam? The crane arm. That's not the right word, but yeah, say this in the image. So this would be and sort of an incident area. This would be a warning area. So this situation here is obviously not very good. Okay. Yeah, and RealTime Dashboard, first version, so doesn't look very nice. We also have a Power BI version of that same thing. Okay. Any questions on that?
I don't speak much Swedish, but I think I saw in one of the slides that said something that the size of the training model was like 500 images.
Yeah, so as I said, so the number of images that we now have for production, so an old slide, but we are probably close to 1,000 annotated images. Yeah. So, but it is too little. We know that we need to annotate more images for future versions. But as we see now, we have an accuracy, if you want to call it that, of around 85%, 85-90%. So we want to be better. We think we can be better, but yeah, we need to annotate more images. So.
The size is very good.
Yeah, absolutely. But as I said, we are using transfer learning, so we're only training the top players in the network. So we're reusing one of the can't remember exactly which network it is, but we're using one of the pre-trained object detection networks. So yeah, could be, or if it's YOLO. It's one of them. Or even some other. I can't remember. I can't remember exactly what. And we've moved between a number of them as well. So which version it is at the moment, I don't really know. So yep. Yeah. Exactly. So 3D analysis. Exactly. That was something I mentioned before. Right now we have sort of images from only from above, which is sort of at the outset of that, it's a lot easier because we don't really need to care about perspective or anything like that. However, there is still all those challenges still remain because if we look at the crane arm, like going like so, I mean you're building a house, right? And that may be 10 stories high. So even if you see something, you see an object straight down. I mean, in one case it's 30 meters up, and in another case it's on the ground, right? Exactly. So that's also something we are building at the moment. For that, we do have a slightly more different or slightly more difficult challenge than in other projects we've done. Yeah. So, but yeah, we have a couple of ideas for how to approach that. So yeah. So exactly. So at the moment we have in total 3 cameras at different places on the crane, looking down. But of course, we have a field of vision that's sort of going out like that. So we cover a decent sized area underneath the crane. So. No. So they're captured from here as well. They're captured from here as well. Yes, exactly.
You mentioned alerts. So are the workers getting alerts like something like vibration, just you're in a danger?
Yeah. So watch this space. There's going to be lots of things happening on that. Notifications at the moment is notification to more sort of back end people, right? So the construction manager, the site manager, for example. We are currently discussing how to notify workers on the ground, because yes, that's the dream scenario, right? That is what we're sort of aiming for. But on the other hand, I mean, sending a text message, yeah, that implies a number of things. That implies you know who it is who's walking under the crane, which means that we're no longer in a um, sort of anonymous data capturing scenario. So now we need to identify individuals. Plus, I mean, okay, something dangerous is about to happen, so please look at your phone. Is not a very good suggestion, right? Um, so there is quite a lot of that, but again, there are a number of ideas, and I can't go into too much detail about them, but there are a number of ideas for what we're thinking. So we are thinking beacons, Bluetooth connected beacons, and so on, notification, yeah, to ground staff. In this case, connected to this, this is much more geared towards making sure that the crane operator is able to get the notifications, because it's the crane operator does have access to horns, and I mean, so making sound and yeah, sending notifications. So we want to make sure that sort of works well. Okay. Yep. Yeah. So yes. But yeah, we have such messy um, scenes anyway, and we're seeing people from the top. So even if there would be a shadow, we I don't I haven't seen that scenario happening. Uh, could it? Yeah, I'm sure it could. I mean, we will not be able to detect people perfectly anyway. Um, uh, but um, uh, but um, but shadows, I don't think that would be a big problem. So. So in this construction site, they don't work night shifts, so we don't really need to um, be sort of have the full functionality overnight, but we do have light sensitive cameras, so we can film and capture frames quite well also at dusk and dawn. So which is important in wintertime in the in Sweden. So. Okay. Any other questions? Yeah. No. No. It's not color based. No. No. I have a feeling that. So I have a gut feeling that we are overtraining a little bit on the colors. But that shouldn't be the case. So and I don't think it's a massive effect. But maybe there may be a little bit of that going on. But yeah. Right. Any other questions? Then we jump into Pepper. Um, and as I said, she's a bit. So she has status indicators here. Um, they are gray at the moment, and I don't know why that is, but we'll have a look at that afterwards. So, Pepper, SoftBank Robotics are the people behind Pepper. We at Sigma Insight, we're partners with SoftBank. This is our, as I said, this is our development robot, where we have a game or an application, or it is configured to work with Karolinska Sjukhuset in Stockholm. But just to sort of um, set the scene a little bit, right? So we are seeing sort of humanoid robotics and so on, and really the place we are at in history is this, right? So the advent of the television, I mean, the television when it came in the 50s and so on, looked completely different to the TV experience that we have today. And of course the robots that we are seeing today, the humanoid robots and the social robots that we see today, of course they will look very, very different in a number of years' time. How long, I have absolutely no idea, but things will happen. So we are seeing quite this sort of revolutionary technology, I think, will turn out in the future. So, I mean, when we talk about robots, and sort of describing where Pepper fits in, we have, I mean, there are multiple sort of perspectives to this. So there's the humanoid devices, or the humanoid sort of appearance of the human body, and as you can see, Pepper has quite a lot of that going on. There's the robotics part of this, with the electronic devices that are basically programmed to do things, and there's the sort of social side of things. Now this is a slide from SoftBank, so they've just exemplified it with IBM Watson. Of course, Azure would do a much better job in there, but the social IA, the social sort of interaction skills and being able to interact is a crucial part. SoftBank is focusing on all of this, and Pepper is one example. They do have a number of other types of robots as well, but Pepper is probably the one that has come the furthest when it comes to commercial implementation. So hardware overview, there's a lot of technology in there. He has safety bumpers at the bottom here. There are lasers and sonar at the bottom, so it understands and can map out sort of the world around it. It has tactile sensors in the hand, so it can sort of feel when I do things. There is a tablet so that I can have not only a voice dialogue interaction, we can also have this sort of graphical interaction. There's a gyroscope in the torso. There are 2D cameras both here, and there are 3D sensors in the eyes. Loudspeakers are in the ears, interestingly enough, and there are also tactile sensors and microphones on the head. So there are quite a lot of things in there. A lot of this can be accessed to some extent through the SDK, but yeah, a lot of this is actually pre-built by SoftBank when it comes to sort of facial expression detection, face recognition, people perception, and so on, speech recognition. when it comes to sort of activity suggestion and so on, mind prioritization, all of that is also taken care of. And then there are output services, text to speech, LED lights, so it can have different lights and animations. Of course, we can program how to move and what to do exactly. Just one example. There are multiple of these. If you, for anyone who has this Nespresso machines, if you do go to an Nespresso store in Japan, there will be a pepper robot in the store where you can use the tablet, and you can use some voice interaction to understand the assortment and so on. And there are many others, Carrefour and a couple of others around Europe as well. So okay, so then what are we doing? Well, one of the reasons why it's a bit shaky is because this is our development robot, because we are currently in a project, or have delivered a project, or the first version of the project, to Karolinska sjukhuset Hospital, Astrid Lindgrens barnsjukhus. So it's a children's hospital. The entire hospital is big. It's probably one of the biggest hospitals in Sweden, or if it's even the biggest hospital, I'm not sure. But the guys that we're working with there is the cancer treatment clinic. So we're talking about cancer treatment for children at this Astrid Lindgrens hospital. I mean, cancer for kids is not a very fun story, of course. The reason for it is unknown to a very large extent. The treatment that these kids go through is quite insane. They get radiotherapy and chemotherapy, and it is really heavy treatments that they're going through, and of course the medical stress that these children are sort of exposed to is quite extreme. So it is a very challenging situation. It's not a very pleasant experience, obviously. The survival of childhood of kids or children with cancer is increasing. So it's been increasing quite dramatically over the years. So things are sort of going better. There is development in the field. Unfortunately, I mean, looking at these sort of heavy treatments, chemotherapy, and so on, the biggest challenges, or a couple of the biggest challenges, are the very basic things, right? So, being exposed to radiotherapy, I mean, yeah, you feel awful, and you're nauseous and you're sick and so on, but I mean, removing a bandage or getting a needle, I mean, those things that have much sort of a more direct pain associated with it. So the little things are actually some of the things that are the toughest for the children. So this child, for example, Alexander, he says that, yeah, I mean, I was feeling good by the medicine, but I was still feeling sick in the hospital because I was afraid of the needle, right? So, so I mean, this is quite interesting, right? So what's the big thing from an overall therapy perspective or a treatment perspective, and the experience for the children is very, very different. So so Karolinska, they work very, very heavily with sort of the preparation, processing, and reward. So being able to prepare, knowing what to expect, knowing sort of, okay, what's going to happen, what happens first, what happens then, and so on and so forth. That means that it's much easier to process things as they happen, and then getting a reward at the end, right? Getting something fun or a toy or whatever. And anyone who was at the doctors when they were a kid, probably also remember getting this reward, getting the little sticker or the little car or whatever it was, right? So Pepper is really being used in this department for cancer treatment, to make the children feel secure and in control and being happy. So that's the overall sort of idea with Pepper. I do have um, the game that kids can play, loaded on Pepper. And as I said, it should be able to speak, but let me see if I can. So let's pause it. Let's see if we can.
Hej, jag är Bertel. Min internetadress är 172 16 2.
So what happens now is it tries to use all the motors and sensors and try to understand what's going on around it. Yeah. I'm not sure. Hey Peppa. Hey Peppa. Okay. Is it the So tell you what, I think let's break there. You are more than welcome to play a little bit with Pepper once I get it working. It may be that the internet connectivity has lost that. I'm not really sure, but let me see if I can get it to work, and you're happy to interact with it afterwards. Is that okay? Yeah. Okay. Any questions on this?
So I was wondering, is Pepper ever trained in her current body? Or, so for example, do you train the language capabilities by themselves and other capabilities by themselves and put it together inside the robot?
Well, no, and I mean what you're sort of getting at there is a little bit of the sort of divide between the robotics and the AI world. Quite often, it's sort of clumped together as one, but in reality, there is quite a big divide between them. So in terms of movements and so on, there is no machine learning going on at all. It's programmed completely from scratch. So. In terms of speech recognition, it is using standard libraries for that, or standard APIs for it. But they're not trained, so it's not something you really have access to sort of train that further as it is, right? So connected to that, I can probably mention. I mean, so the team that we have in Sigma Insight, we are actually split in two. So we have the sort of AI data science team is one team, and the robotics and softbotics with chatbots and so on is a different team. So it's a different set of skills quite often that is required for it. It's much more, as you can see, user experience and so on focused for that. Okay. Any other questions?
Yeah.
Yeah.
How do you encode the actual movements? Do you have somebody with sensors? Because they seem very natural movements.
Yeah, so there's an SDK to do it. There are a number of different ways to do it. You can code with Python, Java. There's a graphical interface as well. You can drag and drop and says if this happens, then do something. Right. So there are a number of ways to do it. But it's yeah, you basically you build that in code basically.
How do you handle the new changes in software development lifecycle with robots? So do you have several robots for dev, test, and prod? Do you have some kind of default micro course, or do you have the same robot and just present to the default settings and then redeploy the new version?
Yeah, so I think that's a good point. They are insanely expensive. So even though I would like to have dev, test, and production robots, we currently only have dev and production. So the production robot for Karolinska is in the hospital at the moment. So that's working in the cancer treatment department. This is our development robot. So yeah.
How often and how actually you release new software to production
That's that depends. It depends, but I mean, there is well, and I mean, it is. So I would say it depends, right? So a lot of so the game, for example, if we take it like that, so the game that we have here that you can try if you want, that's developed as an Android application. So that we can update with a lot sort of higher frequency, and that will run on any Android device. Whereas all the robotic movements and the robotic speech and all of that requires a lot more work. So whereas we upgrade the app and the game quite regularly. I think it's even on the App Store. I'm not sure, but whereas we update that pretty often, the robot itself we upgrade very rarely, I would say. Yeah. Okay.
how flexible is SDK to work with your own data, like connect to your home automation system, make organize your own maps independently, have a map of your home, and all these things?
So a map of your home is not really possible, but in terms of sort of working with home automation systems and so on, absolutely, that's possible. But in order for you to get one of these to work at your home, you would have to be partner with SoftBank. And pay the partners fees for that, and then you would have to buy this, and they probably cost up towards I don't know exactly, but $100,000 or 100,000 kroners or something like that. So they're not very cheap. But they do have the little Now robot, the SoftBank, and that's probably much more geared towards using in your home. But that I don't know what capabilities that has in terms of SDKs. But this one does have that capability. So yeah, so it can do quite a lot. So you can embed code and say, okay, so when you build this sort of user experience in dialogue, you basically build in placeholders and say, okay, when at this point something should happen, right? So all of that is there.
So you have the, I don't know if Center has like a conversation tree or but so you get hands-on with the conversational system. You make actions based on.
Yeah, absolutely. So you configure all of that, and you sort of describe sort of the user experience from a dialogue perspective, and describe sort of how things start, and sort of in which directions things can go, and yeah, you need to take many things into consideration there. So that's probably the biggest challenge in building this. But yeah, we do have all access to all of that, and I can show you some of the examples for how to build that if you want. Okay, any other questions? No? So let's grab some lunch. I'll be here. First of all, trying to get Pepper to speak, and then you're free to come and chat to her, him, it.